Here's a strange fact about language models. Before they could reason, before they could chat, they first had to learn what a word even means to a computer. And the answer that cracked it open came from a small model in 2013 out of Google called Word2Vec. The trick was almost philosophical. You shall know a word by the company it keeps. Word2Vec turned that old idea into vectors, and suddenly meaning became something you could measure. Let's unpack how it works. Now, to feel why this mattered, look at how computers used to represent words. Traditionally, every word was just a slot in a giant list. Cat is position 400, dog is position 9000, and each one is a vector that's all zeros except a single one. Under that scheme, cat and dog are exactly as different as cat and airplane. There's no notion of meaning at all, just identity. The representation knows nothing about what any word actually is. Word2Vec throws that out and gives every word a dense vector, a few hundred real numbers learned from data. Similar words land close together in that space. Cat sits near dog, near kitten, near pet. The geometry itself carries meaning, and that single shift, from arbitrary slots to a learned space, is what made everything downstream possible. So how does it actually learn those vectors? The recipe is beautifully simple, and it needs no labels at all. First, slide a small window across raw text. For each position you get a center word and the handful of words around it, its context. That's your entire training signal, and it comes free from any pile of text you have lying around. Nobody has to annotate anything. Then set up a prediction game. In the skipgram version, you hand the model the center word and ask it to guess the surrounding context. CBOW does the reverse, using the context to guess the center word. Either way, the model is forced to encode what company a word tends to keep. Doing that over a huge vocabulary would be brutally slow, so Word2Vec uses a shortcut called negative sampling. It nudges each true word and context pair a little closer together, and pushes a few random, made-up pairs apart. Cheap, fast, and it scales to billions of words. Repeat that across a whole corpus and something quiet but remarkable happens. Words that keep showing up in similar contexts drift towards similar vectors. Meaning is never programmed in. It simply emerges from the statistics of which words hang out together. Let's pull out the 3 ideas that make Word2Vec worth remembering. The learning task is self-supervised. Skipgram and CBOW invent their own labels straight from raw text, so there's no human annotation and effectively unlimited training data. That framing, predicting parts of your input from other parts, is the same seed behind modern language models. Negative sampling is the engineering that made it practical. Instead of scoring every word in a massive vocabulary at each step, you contrast the real pair against a few fake ones. It turned a heavy computation into something you could train quickly on ordinary hardware. And the payoff is meaning as geometry. Nearest neighbors turn out to be synonyms and related words, and directions in the space and code analogies. The famous example, king minus man plus woman, lands right next to queen. Relationships became arithmetic. Alright, for things to carry away from this one. Word2Vec from Mikolov and colleagues at Google in 2013 popularized dense word embeddings and replaced arbitrary one-hot slots with a learn space where similar words sit close. It learns from raw text using a self-supervised game. Skipgram predicts context from a word. CBOW predicts the word from its context, with no labels required. Negative sampling made training fast over huge vocabularies by nudging true pairs together while pushing a few random pairs apart. Meaning ends up as geometry, where king minus man plus woman lands near queen, and these embeddings became the standard first layer of NLP before BERT arrived. If breaking ideas like this down sounds like your thing, Standarity.com has a whole shelf of them waiting. Catch you there.